Hello, geometry. Welcome to lesson 8.3 on the law of sines. So we've done Pythagorean theorem, we did special right triangles, and we did trigonometry, all focused on right triangles. Well, now we're going to talk about the law of sines, and this is actually a non-right triangle lesson. Non-right triangle. So in these problems, you will not have a right triangle. However, we still want to find angles and side lengths of these triangles, so we have this law of sines that we can use. Now the next lesson is called the law of cosines, because based on certain situations that you were given, you have to use one or the other. Okay? All right, so let's take a look at what the heck the law of sines even is. Right? So it says, how can you use the sine ratio to relate the lengths and angle measures in triangle ABC? So this is a non-right triangle. So how can we create this law of sines to help us find things, angles and sides in this triangle? So we're going to draw the height. All right, it's going to go straight from A, straight down, perpendicular, right, in altitude. And we're going to call it H. So we're going to create two sine equations. So since we came from A, we're not going to use A, right? And as you can see, we created two right triangles using this altitude. So we're going to use B and C. So we're going to do the sine of B. Now I know that we just learned SOHCAHTOA, but sine is opposite over hypotenuse. So in this right triangle on the left, the opposite side from B would be H, and the hypotenuse would be this lowercase c. And we'll do the same thing with angle C. So the sine of C, notice it's capital C, equals, and the opposite from C is H over the hypotenuse, which is B. And notice that both of them have an H in them. So what we're going to do is we're going to multiply both equations by their denominator. So multiply this by C, lowercase c and lowercase c, to get C sine of B equals H. And over here, multiply this by B and by lowercase b to get B sine of C equals H. And now, again, because each of them is set equal to H, we can go ahead and set each equation equal to each other. So we can say C sine of B equals B sine of C. Just a simple substitution. And now, to be clever, we're going to divide both sides by B and C. So on this side, the C's will cancel. And what you'll get, I'll do it over here, is you get sine of B over B. And over here, the B's will cancel, and you'll get sine of C over C. And this is your clever law of sines. Sine of an angle over its side equals the sine of an angle over its side opposite. And again, sine of A over A is also a part of this as well, but you only need to use two at once. And we could do a very similar argument to find the same thing for A. So your formal introduction here. So this is called the law of sines. So for a triangle, side lengths ABC, opposite angles, bigger uppercase A, B, and C, the law of sines looks like this. Sine of A over A equals sine of B over B equals sine of C over C. And again, you only use two ratios at a time. Use two ratios at a time. Now, in a triangle, here are the situations to be given and be able to use this. All right, so first off, you can be given the angle side angle case. So that'd be two angles and the side in between. You could also be given the angle side case, two angles and a non-included side. And you can be given the side angle case. And I'll put an asterisk by that because the side angle case is rather interesting. Sometimes, and again, I think you're going to do some in your homework, sometimes you can get two possible triangles. And again, we'll leave that for our bell work. I think I'm going to input that into your bell work and also your practice. Okay? But again, notice here, if you have two angles, you can pretty much do this law of sines because you can always find the third angle. And then you have an angle and side opposite pair. All right? Cool. All right, so let's take a look at example 2 here. Okay, so it says, what is yz to the nearest tenth? And we're actually going to change these directions. We're going to do what's called solve this triangle. Solve the triangle. So basically what that means is I want all 6 pieces, right? So in the end, I want to know what the measure of angle x is, Now on Savas they just call it capital X, but I'm going to do better here. What the measure of angle Y is, what the measure of angle Z is, and then I want to know what lowercase x is. And again, I haven't labeled it yet, but if this 51 is x, then this is lowercase x. What x is, what y is, and what z is. And again, if this is angle Y, then Y is here. If that's side Z, then Z is here. So you already know some things, right? Angle X is 51 degrees. Angle Y we don't know. Angle Z is 77 degrees. And side Z is 7. All right, so this situation would be the angle side case, right? Angle side. ZX and lowercase z is angle side. So this can be done using the law of sines. Now, because you know z and z, right, you can go ahead and start by finding x, right? I could also find angle y right now if I want to, all right? But I'll just start by finding x because I'm able to. So we're going to do the sine of x over lowercase x, because that's what I want, is sine of z over lowercase z. I know x is 51 degrees. I don't know lowercase x. I know angle z is 77 degrees and side z is 7. So you need to cross multiply and divide, okay? All right. So when I do that, it's going to become x sine of 77 degrees equals 7 sine of 51 degrees. Notice I put the side in front, right? And now to get x by itself, I need to divide both sides by the sine of 77 degrees. And this right here is what you're going to input into Desmos. And we're going to round, it says the nearest tenth, that's fine. So I'm going to do that with you here. So 7 sine of 51 over sine of 77. This is going to go away. I'm going to try to keep it. Hold on. Oof, I don't want to lose all this. Okay, but we'll see. No, it's going to go away. So sine of 7 sine of 51 over sine of 77. Wait, that's sad. So remember, first off, wrench, degree mode. So in here, I'm going to put a fraction bar. 7 sine of 51 over sine of 77. Right? Now sometimes you want to make sure you put parentheses around this 51 depending on the type of calculator you're using. Because you don't want that sine of 77 to be inside there. But for Desmos, you don't need to. And here we go. I'm going to do the nearest tenth. I'm sorry, 2 decimals, the nearest hundredth. So this is going to be 5.58. Okay? So 5.58. So if I come back here, oh, it's so sad, it was all gone. Okay, so again, up here, I'll use capital letters this time, so I knew x was 51 degrees, y I don't know, z is 77 degrees. I just found x to be 5.58, and I don't know y, and I know z is 7. So now to find angle y, this is where you have the 2 angles of a triangle, so add them up, 51 plus 77, that's 128. And then subtract that from 180, and that is 52. So I know that angle y is 52 degrees. And now I use the law of sines again to find side y. So I'm going to do sine of y over y equals, and because I found x and rounded, I'm not going to write or use x's, I'm going to use the z's again. Sine of z over z. So that is sine of 52 degrees over y equals sine of 77 degrees over 7. And you will see that because x and y angle measures are relatively the same, you're going to see that x and y are going to be the same. Y will be slightly bigger because angle y is slightly larger, right? So if you remember that whole, I think it was topic 5, right, in the triangle inequality theorem and all that fun stuff. All right, so same thing, cross multiply. So y sine of 77 equals 7 sine of 52, and then divide by the sine of 77. And you'll see that if you use Desmos, you can just manipulate some of your calculations, because if you look here, this was very similar to what we typed in before. We typed in 7 sine of 51, now it should be 7 sine of 52, divided by sine of 77. And this will give us our y. All right? So we'll go back to there. Desmos. So like I said, just call that sine of 52, and you can see 5.66. So in this problem here, so angle X was 51 degrees, angle Y was 52 degrees, angle Z was 77 degrees. X was 5.58, Y was 5.66, and Z was given to you as 7. And there you go. And that's called solving the triangle. So I kind of changed the direction, sorry. Oh, there you go. All right, that's the end of video 1. Video 2 is coming up.